So welcome to Friendly Fabulous Fractions. I've called it friendly because fractions is my 100% favorite topic when it comes to math. I wanted to start the session by just running through the progression of skills when it comes to fractions, the progression of skills and knowledge from reception through to year 6. So I know that with Number Champions, you've got your age range, but it's always helpful to know what has come before and what the children will be moving on to afterwards. For example, with reception and year 1, what we're looking at is children understanding fractions as sharing. So from a young age, I'm sure you've all done it before at home with your families and friends and so on. You know, you might have a pizza, you cut it into halves, you cut it into quarters, and you share. You might have some objects, you might have some fruits, some sweets or whatever, and it's all about sharing. It's all about equal sharing. So, you know, one person gets an amount, another person gets another amount, but it's about the equal parts of a whole. Reception, year 1, we introduce young children to what we mean by halves and quarters and beyond. And how do we do that? Well, we can use objects, we can use amounts, we can use lolly sticks. If one group hasn't got the same number, what can we do? And so on. So it's about encouraging that rich vocabulary and that rich talk. By year 2, children are introduced to unit fractions. A unit fraction is a fraction with number 1 at the top. So a quarter, a half, a third, and so on. So we introduce children to unit fractions because they're the most common one, but we also introduce children to non-unit fractions. For example, 3/4, which is a common one. And in year 2, we encourage children, we're showing children how to read and write fractions in context. And for example, at home, we might say to our families, look, we're leaving the house in half an hour. Make sure you're ready by the door. So this is how we can use fractions in everyday language. We're leaving in half an hour. You've only got a quarter of an hour to get to school. So this is how we are talking to our children from a very, very young age. And we are using the vocabulary, we are using the language of fractions. We do it incidentally, but I think, you know, for children in year 1 and 2, we really have to make sure that we make the language explicit so that they understand what we mean by half of an hour and a quarter of an hour. By year 3, children are working with equivalent fractions, 2/5, 4/10. How do we get there? Well, that's by multiplying and dividing the denominator by the same amount. We look at fractions of shapes. So, you know, if you've got a rectangle or you've got a square or a circle, we're going to divide it into equal parts and so on. Fractions of an amount using bar models. So, you know, you've got a rectangular bar and you split it into a certain number of pieces. So if I've got a rectangle here, it's not a perfect rectangle, and I'm going to divide my rectangle into 4 equal parts, and I'm going to take one of these. I've taken 1/4, I've taken 1 out of 4 parts. Okay, so the denominator is telling us the number of equal parts, and then the numerator is how many of those equal parts are we going to have. So, you know, that's what we mean by bar modeling, the rectangular bar, and so on and so on. Then we've got addition and subtraction of fractions with the same denominator, like 1/4 plus 3/4. Yeah, so, you know, so my denominators are the same. My denominator does not change. 1 plus 3 is 4. So 4/4 is the same as 1 whole. And then we're subtracting fractions with the same denominator. So it could have been 3/4 subtract a quarter, which would give us 2/4, which is the same as a half. So it's all about the visual. And by coincidence, the example that I've given you is about finding complements to the whole. 3/4 plus a quarter, they complement to make one whole. Decimals are introduced as tenths and then hundredths by year 4. So we're looking at how to compare them with our fractions, 1/10, 2/10, and so on. By year 5, we're looking at fractions of amounts and multiplication of fractions by a whole number and another fraction, and how to divide a fraction by a whole number. By year 6, we're looking at improper fractions and we're looking at mixed numbers. When it comes to working with children and fractions, it is about the use of manipulatives. You've heard me talking about the bar models. You can use cakes, pizzas, objects, fruit, vegetables, whatever you've got, lolly sticks, matchsticks, and so on. But it's actually getting children to actually physically move, to make sense, and to consolidate their thinking and to visualize what they're doing. What are fractions? Well, to put it simply, fractions tell us how many parts of a whole we have. These are just some of the documents and some of the books that you can get online. White Rose, a very, very popular scheme. Mathematics Mastery. We've got the CPA, which is concrete, pictorial, and abstract. And this is the way children move from one concept to another. So it's the concrete where they're touching, they're holding, they're moving. Then the pictorial where they're representing what they can see. And then you've got the abstract where you're moving away, but it doesn't mean that you still cannot use manipulatives and pictorial to help and support your learning. What is the intent of your lesson? What are you aiming to get from teaching this? How do you intend to implement what you're going to be teaching? And what is the impact? What is the learning outcome? How can you measure the success criteria? And what am I looking for? How will I be able to measure the impact? Is it through questioning? Is it through what the children can show me pictorially? Is it through what they can write? Is it their understanding and use of vocabulary in the right context? So this is all part of the impact. And White Rose gives you different levels. It gives you the more able, it gives you the working towards, and it gives you the children who are emerging, who are not secure, but they are working towards secure. And then it also gives you ideas for children who are working at greater depth, and that's the high achievers. So a little visual activity. I've got 3 squares, the same size, and I'm just going to pose the question, what fraction of these shapes is shaded? How would you go about working with these three shapes if you are working with a young person? I've just put some little lines at the top. So we've got 1 part, 2 parts, 3 parts, 4 parts, 5 parts, and then we've got 6 parts, okay? And as you just said, that we've got one out of 6, 1 is unshaded, and there are 6 equal parts. Or what about shape number 2, the one in the middle, and then shape number 3 on the right-hand side? I would somehow show the young child that, you know, let's do some dividing up, let's do some partitioning, let's share this whole shape, and maybe you can get 3 equal parts, so 3 horizontal, so 3 horizontal lengths, and then we can divide it vertically down as well. So if we've got 9 equal parts, then we can turn over 4. What is left? How many parts altogether were there? They should be able to use a ruler from end of year 2 going into year 3. Use of a ruler in year 2 is that because in the year 2, in the Key Stage 1 SATs, they have questions where they have to be able to know how to read and interpret the intervals on a ruler. And in all classrooms, we do use the standard 30-centimeter ruler. So children are taught and that when we are using the ruler, we start from the 0, and we do not start just from the end of the ruler where there are no numbers or numerals. And then we teach them how to count along 1 centimeter, 2 centimeters, and so on. So they will be able to use the ruler, but maybe if we're going to start asking them about to count how many centimeters and then divide by so forth, that might be challenging. So it depends on the ability of the child.
The other volunteer at the school that I work at, she had a really good idea, and I did it too. She suggested, and did it with her kids. We asked the children to draw a 10-centimetre square, and so that was really good for their fine motor skills. And they really enjoyed drawing the square, and then they could do things like cut it out or colour it in. My kids always love taking away something like a paper square that they've measured.
Yes.
So it doesn't have to be great things, but that was really good to see that they do know how to use a ruler, or I showed them. That's what we also did, was then we cut them into half, and then we cut them into quarters and talked about halves and quarters doing with the squares.
And then straight away, Angela, when you started talking about halves and quarters and three quarters, that is about combining fractions. A quarter plus three quarters, they're going to go back to their whole again, cutting and origami and putting shapes back together again, and tessellating. Tessellation is so important for fractions. And then the last shape, any ideas on the last shape?
I measured it again. I cheated. 9/10.
I've used the word approximately because some children will want to find the actual amount. Oh, that's
Isaac,
good.
Would you
Yes.
encourage the children to make a guess at what they think? So, for example, the last one.
Yes, I would. Yes, Lorraine. I mean, that's why I've used the word approximately. They're making a guess. How much of that shape do you think has been coloured in? And it's interesting to listen to their responses. Because some children will say, oh, a lot of it has been shaded, which is fine, because they've got that idea of spatial awareness. There's more of the orange color than there is of the white color. And for me, that's important. What can they see? What can they talk about? And what do they know? More than half, less than a half? For the more able child, is it more than a quarter, less than a quarter, more than three quarters? Then that's when the rich language and the rich learning comes up. And that's what's really important. For example, if I've got 2/5 here, I'm going to shade two of these 5 pieces. Right, now I'm going to shade 3 of these 4 pieces. And my simple question is, which fraction is larger? Is it 2/5 or is it 3/4? Some children are going to say that 3/4 is larger, bigger than 2/5, because the pieces are bigger, the slices are bigger. But if I was to shade in like this and ask the children which fraction is bigger, 4/5 or 3/4, then something else has to come into play. And the way that I'm looking at these 2 rectangles is that these 2 rectangular bars, they are exactly the same size. They are exactly the same length. They are exactly the same width. That's the only way we can compare them, because they are exactly the same size. It's like having 2 birthday cakes. They've got to be the same size. The slices on the 3/4 are going to be bigger than the slices on the 2/5, but we are eating more of the cake when we've got 4/5 than when we've only got 3/4. We've eaten more of this cake. More of the rectangular bar has been shaded than the 3/4. So that tells us that the fraction 4/5 is bigger, greater than 3/4. So for example, you could give them 6 rectangular bars, the same size as each of these, and then you can divide them up into different denominators. So this one has got 5, this one's got 4, another one might have 6, another one might have thirds, and so on. And they simply shade what the numerator bit is. Then you say to them, which fraction do you think is the largest? And they have to sort of look, and they're going to say, well, the thirds have got bigger slices than the halves, or bigger slices than the fifths, or whatever. And so you can say to them, right, but how much of the bar has been taken up? Then they start to get the idea, the concept of it's part of the whole. How many parts of the whole have been taken up on the rectangular bar? And I think this is the key learning that we need to be getting across to our children. And I've just put on there, the two rectangular bars must be the same size. Allow children to talk about the size of the individual pieces in each bar. And I spend a lot of time just talking to children. Okay, the 3/4 have got bigger slices, but does that mean I'm getting more of the pizza or less of the pizza? And then they start to understand, you know, so this is the visual representation. 2/5, 3/4. The light blue there's a lot more light blue than there is orange, bearing in mind these rectangles are exactly the same size. So 3/4 is bigger than 2/5. Why? Because more of the whole has been taken up. I've put down some fractions, okay? Now, year 2 children, some of these fractions will not apply to them. So you will need to choose the fractions that are applicable to your age range. I've got 5 strips of paper. I've got 5 rectangles. The first one I've divided into 5 equal parts. I've colored in 2. The second one, I've got 3 equal parts. I've colored in 1, and so on. And then I've put them on top of each other. Either I've laid them physically on top of each other, or I've put them underneath each other. And I've asked children, what can you tell me about 1/3, and what can you tell me about 3/4? Obviously, for year 2s, I would not have 2/5. I would have 1/3. I would have 3/4, but 3/7 and 2/9, perhaps not. But visually, I would show them what these fractions look like as bar models. We can use cakes and we can use circles that have been cut into 9 pieces and you've shaded into, or indeed you've taken away to, and so on and so on. We're looking at the age range and we're looking at the ability of the children that we are working with. And I've just made up my fraction story. And it's just about a young child going into a bakery, sees some cake, can't decide on which ones to buy because he or she's not too sure about the pieces and how much of the whole they're going to get. And the reason why I tell this story is just simply to attract children into wanting to learn about equivalent fractions and just to get their interest. And as we know, year 2 children, year 1, year 2, year 3 children, they love stories. And I think it's just the way that I've just tried to dramatize fractions. So we've got 3 characters and we've got the bakery, the best in town. This is Timmy, and Timmy is learning about equivalent fractions. One day, Timmy saw some cakes in the bakery window. There was something unusual about them, so he stopped to take a closer look. Timmy looked closely at the 4 cakes in the window. One of the cakes was partly covered in a rich, dark chocolate topping. So 4 cakes, and you got the dark chocolate topping on the first, on the second, third, and on the 4th. Timmy looked at the other cakes. Some parts of the cake were covered in the rich dark chocolate too, but these parts looked and were different. So which of these cakes below has the same amount of chocolate as this cake here?
Sorry, I think it's number 1, number 2, and number 3.
So if you're working with your child in year 2, how might you explain the chocolate covering on the cakes?
Let me guess to try. Number 1 and number 2, they like mirror reflections, so there is no great difference. Yeah, so it's easy for child. If you're talking about number 1, the left part is covered with the chocolate. In number 2, the right part is covered with the chocolate, but they are identical. They like 2 parts looking in the mirror.
Thank you. And then what about the third chocolate, the third
Yeah.
cake?
Sorry, I have a clue. We can use a line of symmetry. If a child already knows
Ooh.
some symmetries, we can use a line of symmetry to explain number 3 as well.
That's funny thought, Timmy. Most of these cakes look different at first glance, but they really have the same amount of rich dark chocolate. That's clever. He then saw a few more cakes behind the others and tried to figure out the fraction represented by the chocolate on each of them. Right, so this is what Timmy sees next. And Larissa, you mentioned about symmetry and you mentioned about the lines, and look at what you've got there for cake number 5.
It is second, third, and the last one.
The second,
Third and the
Yeah.
last, fifth.
why do you say the last one?
Last one, even though it is divided into 8 pieces, when you see as a whole, the cake has been divided into 2. Visually, we can see it is divided into 2.
It's and I put it at an angle on purpose because I was told by a psychologist that children see things differently, and just to try with the diagonal as opposed to the horizontal and the vertical. And it is interesting, children's responses. Great news. That's great. It's neat thought, Timmy. It looks like a half, 2 quarters, and 4/8 represent the same amount of topping. I did not expect that. Trouble in store. Timmy decided that he wanted some cake to eat. He went into the bakery. Mr. Crumble, the owner, was not in, but Sprinkle, the assistant baker, was behind the counter, and in front of him were 2 cakes and a label saying £10 for half a cake. Okay, here we go. Timmy pointed at the cake on the left. Hello, Sprinkle, he said. Could I have half of that cake for £10? So half of this cake on the left for £10. Sprinkle looked sneakily. He said, that cake is for somebody else, but I can sell you some of the cake on the right. They are the same, of course. Okay, cake on the left, cake on the right. Okay, said Timmy, then I would like some of the cake on the right, please. Can I have the 4 pieces with the rich dark chocolate on them? Sure thing, said Sprinkle, but that will be £40, please. Timmy said, but I'm only asking for the same amount of cake. Why am I being charged so much? Oh, well, said Sprinkle, you want 4 out of 8 pieces of a cake. That's 4 pieces. 1 piece costs £10, so 4 pieces will cost you £40. What's your problem? Just then, Mr. Crumble walked in. Sprinkle, he said in a stern, concerned voice, please go and clean a cooker at the back room. You've left pieces of apple all over the stove. Sprinkle was not happy at this request, but went out to the back of the bakery. Timmy, said Mr. Crumble, Sprinkle was wrong. I am so sorry. You can have the 4 pieces of £10, as the sign says. It's the amount of cake that matters, not the number of individual pieces. But, said Timmy, this fraction is 4/8. So do I write this amount as a half or 4/8? They look the same to me, but the fractions are completely different. That's a good question, said Mr. Crumble. Many fractions can represent the same amount. If you divide an amount into more pieces, it doesn't change the amount. 4/8 and a half are just different ways to name the same thing. You can use any of them because they are equivalent fractions. And that's the end of the story.